Hey, last thing we talk about here is looking at heat exchanger tube failures. And in the drawing you have here, figure 6 text 17, you'll see we have a high pressure fluid here with a head tank essentially on the high pressure fluid, and the low pressure fluid is on the shell side. So there's a tube failure, and we should recognize that the pressure on the high pressure side is going to force the high pressure fluid into the low pressure fluid. So in this case, that's going to result in this tank level actually going down because it's on the high pressure fluid. Now, if we had changed these and we put this as the low pressure fluid, well, I know that the high pressure fluid would flow into this low pressure fluid and this tank level would rise. So you really need to understand this knowledge requirement, the consequences of heat exchanger tube failure, and what would happen to, say, a head tank that's in the turbine building or the reactor building. And also, if there was an oil to water heat exchanger failure, that's going to create a density issue. We know that the oil is going to sit on top of the water because it's less dense. And so I'm going to have a high level, but since it's less dense, it's not going to indicate accurately. It will end up resulting in level actual being greater than indicated level because of the density difference between the oil and the water. And that's heat exchangers. So we'll get to the questions here in the exam bank and see if we can apply these equations and apply some of this knowledge and answer these questions.